So a tri-square is really important, but if you don't hold it right and you don't use it right, it's going to tell you lies. So if you're not used to using a tri-square in your work to check your work, it's important that you hold it the right way. And what I tell my students when they're first starting out is only hold it by the inside of the head. So this little piece of material here, I call this the web. The web of your hand should be with the web of the tool. And by doing this, you're less likely to put strange forces on it. All of the force should be applied through this face. This is just a telltale. It's just telling you whether the surface that you're checking is square or not. So if you have a reference surface like this one, we can check the end of the board by first getting the stock against the reference edge and then bringing it down and checking to see if it's square. And I can see that this is not. You may not be able to catch it, but this side is floating just off of the edge. Okay, so I've pushed it up against the edge, brought it down gently, and made a quick check. Now the same principle applies when you're checking out the edge of a board. So if this is your reference face and you want to know if this face is square to this one, you press the stock against the reference face and then you gently bring the square down, and you're probably going to want to check it in more than one spot. So rather than just dragging it across, you lift it up, slide it down, bring it back down slowly, bring it back down slowly. Work your way across in steps, and you're not smashing it down into the wood. You're bringing it down until one part of it touches or the whole thing touches. And whatever side is high will touch the blade, and you'll know that that's the side that needs to be removed. You'll see some people rolling the square to one side or another to make it easier to see the shadow. What they're doing is, instead of checking it against this whole flat edge, or whole flat surface, this is sort of like the side of a very narrow rectangle, they're rotating it so that it's only on either the front edge or the back edge, and that can make it a little bit easier to see if there's light getting under. The problem with that is you can't roll it very far before the geometry of the square starts to cause you problems. So any of these squares is really good at telling you whether your work is square in these two axes. But once you start rolling the blade from side to side, you're changing the geometry, and the square isn't perfect in those dimensions. And I have tried this test with a lot of different squares, even very expensive squares, and they all fail it. And let me show you what I'm talking about. If you take a pair of squares and you're certain that the blade is flush with the surface or just behind it, same thing here, nice and flush, and you put them 90 degrees to each other like this, and you bring one square up to the other, you're going to find that this blade is not sitting square in the body relative to this surface down here. And, you could say, well, that's just a cheap square, maybe it's wrong. Well, let's check it. It's out too. And I noticed this when I was rolling a square to check an edge, and as I rolled the blade, there was a tiny gap, and if I took it too far, the gap actually got bigger as I rolled it. So if you want to take this as an exaggeration, you can say that you've got your blade up here on this edge, and it may be square, but it's not square in this plane. So when I roll it, it brings the square up. So you can't roll a blade too far, or you're going to run into problems. And just to kind of prove my point, I'll go get the gold standard of squares and we'll check it as well. This is a Vesper square. This one was certified out to like 0.0000 millimeters. This was like one of the finest squares he has made. And if we check the Starrett against the Vesper, we find the same result. And now if we go the other way and we check the Vesper against the Starrett, look at that. It's not square in this dimension. It's only square in that dimension. So use your squares to check these two planes. Don't use it to check these two planes. So as you saw from that example, if you're going to roll the blade, just roll it a little bit. Don't go leaning it at 45 or 30 degrees. We're talking just 2 or 3 degrees off of square. if you're using the combination square to check measurements and you need something like 5 1/16, but the 16ths are out here on the edge instead of down here where the stock is, don't be afraid to flip the blade around. You just loosen the lock nut, slide it out, flip it end for end, and put it back in. And now you've got the 16ths against the stock, and you can slide that blade over until you split that graduation in half, and you can measure exactly 5 1/16, or any other measurement you need. You can also use a combination square to check the inside of a corner. If you're careful to get that flush with the stock, again, it's the same process. You're going to push it up against the face, and then you're going to slide it up and use the blade to check it. And also, if you have a pair of joints that are too close together and you can't get this blade in between them, you can always extend out past and slide the blade up the side, just so long as you can get the stock in there. And that's where having that smaller square with a really simple shape comes in handy. You can bring it up here and you can check it this way. You can look to see that this edge is square with this edge. So there are a lot of ways to use a square to check your work, but as far as I'm concerned, there's really only one way to hold the square while you're doing it, and that is by the stock. You don't want to be holding it by the blade, and you don't want to be holding it by the blade and the stock together. You want to just use all of your force on the stock here against the reference face, and then you're just showing the blade to the work.